day, viewers and my students. I have to continue from where we stopped in the previous video on mass volume relationship. In the previous video we did or we solved problems on equations where the mole ratio is just 1:1:1. But this time around, we want to look at the ones that the mole ratio is not like that. So we have this question now to solve. Calculate the mass of nitrogen required to produce 11 dm³ of ammonia. Calculate the mass of nitrogen required to produce 11.2 dm³ of ammonia. We are given the atomic mass of nitrogen 14, hydrogen 1, molar volume of gas at STP 22.4 dm³. So it requires that we write the equation, and we're saying that nitrogen is a gas, combines with hydrogen, which is also a gas, to produce ammonia, which is also a gas. And I want to balance the equation. Just have an atom of nitrogen here, and we have two atoms here, which is a molecule. So we can take 2 here. And when we do that, we now have 2 times 3 becomes 6 for hydrogen. So putting 3 here balances it. In this, you see that we have 1 mole, 3 moles, and the 2 moles. And we are concerned with nitrogen and the ammonia, where the mole ratio is 1:2. So the next thing to do is to find out what is the number of moles in 11.2 dm³ of ammonia. Like I mentioned in the previous video, we can always approach solving this from another way, even from Gay-Lussac's point of view, but this is particularly under mole. So maybe in the subsequent videos, I can even show you the way we can approach it using Gay-Lussac's law and Avogadro's law. But this is specifically applying it through moles. So let's find the number of moles in 11.2 dm³ of ammonia. So we bring our formula, which I had already given you in the previous video, where we said number of moles equals to volume over molar volume. Why are we using this? We're using this because we were given the volume, which is 11.2 dm³, molar volume. So what's the volume? 11.2 dm³. What's the molar volume? 22.4 dm³. So you see that this is just 1/2, which is 0.5 mole. 5 mole. So if the number of moles is 0.5 here, it means that the number of moles here will be 0.5 divided by 2, which is 0.25 or 1/4, as the case may be. So the mole ratio says 2:1 or 1:2. Therefore, 0.5 is to 0.25. If we have established that the number of moles there is 0.25, then what is the mass equivalent? What's the mass equivalent? When we find the mass equivalent, we can always get our answer. Because the question says, calculate the mass of nitrogen. We have established we can say, let's put it this way, therefore, number of moles of reacting nitrogen, let's put it reacting nitrogen, will be 0.5 divided by 2, which is 0.25 mole. So can I say mass of nitrogen? Don't forget the nitrogen is a diatomic gas. So we're looking at N2, which is 14 times 2, which is what? 28 grams per mole. So can I say mass equals to number of moles multiplied by what? By molar mass. By what? Molar mass. So we have a molar mass, which is 28. The number of moles is 0.25. 0.25 times 28 will now be equal to what? That is divided by 4, which will give you 7 grams. 7 grams is your final answer. So if you have any question on this, do well to talk to me in the comment section. Like I said before, We have other methods we can apply in solving this, but this is the method or the approach I have taught most of my students, and it's easy for them to solve the problem. Thank you.